complex what we have done yesterday, that was just to find modulus and argument and to express the given complex expression in the form a plus ib. This is what we have done yesterday. Now all the today's problems which we are going to solve, I will give you the entire list of problems, and then we will have to rather 1 2 3 4 5, almost all of them are prove that type. Okay, but in a slightly different way. Like the first one, he says, you can take down later, just see them first because I will be explaining them one by one. He says alpha plus I beta is 1 upon a plus ib. This is given to us. Alpha plus I beta equal to 1 upon a plus ib. He wants us to prove that alpha square plus beta square into a square plus b square is equal to 1. Actually the simplest one, because if you take mod of left hand side, it will be alpha square plus beta square root. Mod of right hand side will be. Now this is what we want to know. K, if it is 1 upon z, its mod, will it be 1 upon mod z? Mod of 1 upon z, will it be equal to 1 upon mod z? Yes. Yes, answer will come slowly, but yes, answer will be yes. A reason is obvious. See, 1 upon a plus ib can be written as a minus ib upon a square plus b square. And now if we take the mod, it will be 1 upon a square plus b square is just a real number, and mod of a plus ib, a minus ib, it will be root of a square plus b square upon a square plus b square, and so it is 1 upon root of a square plus b square, which is nothing but 1 upon mod z. Once that is known, then root of alpha square plus beta square, take mod of both sides, will be equal to 1 upon mod of a plus ib. So root of alpha square plus beta square equal to 1 upon root of a square plus b square. Cross multiply. It's proved. But this is important part. This is we should know. It is yes, as nobody will ask us to prove that, but it can be proved easily. Then the second one. See them. See all of them, and then you take down. Shripad. Z equal to x plus iy. And capital Z is equal to capital X plus I capital Y. Show that if small z is equal to z minus 1 upon z plus 1 is capital Z, then x square plus y square equal to x minus 1 bracket square plus y square upon x plus 1 bracket square plus y square. See the problem carefully, and then, because now here onwards the problems you will have to think really. There will be a different procedure for each one of them. This is what is given to us. If we go on substituting it, then will it work? I find that yes, because it is z minus 1, so it will be x minus 1, z plus 1, so it is x plus 1 plus iy. Then he is taking mod, so is it really working? Because now the next question will be whether mod of z1 by z2, will it be equal to mod z1 by mod z2? Yes. And so this problems become simple. We substitute both sides and just take the mod, it is proved. Okay. Third. So this is one more. Of course, one can always write it as it is r1 e raised to I theta 1 upon R2 e raised to I theta 2. So when you take mod, these two terms will vanish. It is R1 by R2, that is mod of Z1 by mod of Z2. Third problem, he says x square plus y square equal to 1. Prove that 1 plus x plus iy upon 1 plus x minus iy equal to x plus iy. Now there are no squares, so we are switching over from modulus to something else, right? Of course, as right hand side is a single complex number, you will have to multiply by the conjugate. That will lead to 1 plus x plus iy bracket square in the numerator, because 1 plus x is real part and y is imaginary part. Similarly here, so it will be 1 plus x plus iy, you multiply numerator and denominator, it will be 1 plus x plus iy bracket square upon 1 plus x bracket square plus y square. Right. Then you can multiply in the numerator. A plus, matlab you will have to square it, can't help. And then in the denominator it is 1 plus x bracket square plus y square. If you square it, it is 1 plus 2x plus x square plus y square. Out of that, x square plus y square is 1. So denominator will become 2 plus 2x. And in the numerator, we must get something such that this 2 plus 2x will cancel and we will be left with this.
X plus I minus z घेतलं तर
हाँ.
mod z square is 1
Right.
and then that is 1 plus z upon 1 plus z bar.
But then
We can prove now because mod z square is 1 and that is mod z square होता है z into z bar.
what she is trying to say is, she is saying that let z is equal to x plus iy, and so this LHS becomes, as per her, it is 1 plus z upon 1 plus z dash. Fine. So
And mod z square is 1 x square
mod z square is 1, right?
and mod z square is z into z dash.
Mod z square is z into z dash. Mod z square is 1 is given to you. That is nothing but z into z dash is equal to 1. So you are saying that replace it. It is z dash plus z upon
z dash काढून टाकलं तर z च्या टर्म्स मध्ये इक्वेशन.
okay 1 plus z upon 1 plus 1 by z. Fine, this will be much more easier. 1 plus z, this z will go up upon z plus 1, which it will cancel. Right. This can be done, but may not be for everybody. Right. So there are two methods. If it doesn't click, because you will have to know that z dash is also 1, because mod z square is z dash. But otherwise you can simply proceed and that 2 plus 2x will cancel. Okay. So we'll complete first 3 and then we'll go for the next 3. The procedure that we follow over here is, though I am telling you how to solve, I am not solving it for you. So you will have to remember, solve it, get stuck, get it cleared, and we move further. Right? आत्ता सोपे आहेत, पुढचे त्रासदायक होतात. And these are the new things one should remember. We unnecessarily get confused and people multiply by all these, equate alpha and all and whatever, they come up with this final answer. That is not required, simply mod will suffice. Here we are assuming that let z is equal to x plus iy, and so z dash will be obviously x minus iy. In the fourth problem, it is given that mod z is equal to 1 and z is not equal to 1. Prove that z minus 1 upon z plus 1 is purely imaginary. A square plus b square plus c square equal to 1, comma b plus ic is equal to 1 plus a into z. Prove that a plus ib upon 1 plus c is equal to 1 plus iz upon 1 minus iz. Sixth, a equal to cos theta plus I sin theta. Prove that 1 plus a square equal to 1 plus 2 cos theta into bracket cos theta plus I sin theta. So that would be the next 3 problems. So in the first one it is given that mod z is 1 and we are required to find out z minus 1 upon z plus 1. So we will now take probably the reverse way, that is let z equal to x plus iy, because then, so I am trying the fourth one, it can be x plus iy minus 1 upon x plus iy plus 1, and I will try to simplify it. So it becomes x minus 1 plus iy upon x plus 1 plus iy multiply and divide by x plus 1 minus iy. So I am getting rid of complex number in the denominator. Numerator can be multiplied x a1 a2 minus b1 b2, right, plus I into bracket, this is x plus 1 into y minus x minus 1 into y upon denominator will be x plus 1 bracket square plus y square. We will have to simply prove that the real part comes out to be 0. That means we should be concentrating on this. If this term comes out to be 0, we succeed, and it is 0. No? We don't have to simplify anything else. This becomes x square minus 1 plus y square, but mod z equal to 1, that is root of x square plus y square is 1. So this is real part, we get rid of it. Baki jo bhi hai wo rehne do, uska kya? Even if we don't simplify it, the moment we get real part as 0, we say that it is purely imaginary. We can simplify, some cancellations will happen, xy cancels, right? It is y plus y, 2y bataya. So it becomes 2y upon denominator mein, it is x square plus 2x plus 1 plus y square. X square plus y square is 1. So it is 2 plus 2x. So 2 plus 2x. Ultimately it becomes iy upon x plus 1. Now in the fifth problem, सब कुछ उल्टा सीधा दिया है इसने. The question is from where should we start? Because he has given b plus ic equal to 1 plus a into z, and here it is a plus ib, and this information is additional. Can we start from somewhere? It appears that we can start from right hand side, because I can determine z at least. So we can say here that from here z is nothing but b plus ic upon 1 plus a, and let me start with RHS only. 1 plus Iz upon 1 minus Iz, substitute Z and proceed. We'll end up with left hand side. There is no point in starting from LHS, because even this is of no help here. Even if we take mod or anything, this is not a complex number, so we are not going to multiply by this. Cross multiplying also is not going to help, because it is proved that. Better to start with RHS. What will happen next? Probably it will be 1 plus B plus IC upon 1 plus A upon, and of course I is there, 1 minus I into B plus IC upon 1 plus A. 1 plus A will get cancelled. It will become 1 plus A plus IB minus C upon 1 plus A minus IB plus C. Good enough, at least I am reaching somewhere 1 plus A, IB. Right? So it becomes 1 plus A minus C plus IB upon 1 plus A plus C minus IB, multiply by the conjugate, and then we are likely to get that particular term A square plus B square plus C square, because when you make square of this, square of three terms we know, A plus B plus C bracket square is A square plus B square plus C square plus twice AB plus twice BC plus twice CA. So this will become 1 plus A square plus C square plus 2A minus 2AC minus 2C, and here it will be plus, you will be cross multiplying. Karo. It will be done from RHS, that is important. And the sixth one. Okay, so now in the sixth one, start with LHS only. You will require some trigonometric formulae, I suppose. What will be A square? A square will be cos theta plus I sin theta bracket square. So it will become cos square theta minus sin square theta plus 2i sin theta cos theta. Of course it is e raised to I theta bracket square, so obviously it has to come out to be e raised to 2i theta, so cos 2 theta plus I sin 2 theta. So but when we add all of them, 1 plus A square, and answer is still in terms of cos theta and not 2 theta, so there is no point in going for cos 2 theta. So it will be 1. So sometimes 1 plus cos square or 1 minus sin square should be put as cos square. That is what is appears. We will start with LHS, saying that 1 plus cos theta plus I sin theta plus cos square minus sin square, cos square theta minus sin square theta plus 2i sin theta cos theta, and I suppose we get the answer, because 1 minus sin square becomes cos square, so this will be 2 cos square theta plus cos theta, and if you take I sin theta common, yeah, we will get it, right? Karo. It is group of 3 problems is always easy, at least, and I have kept everything here only. Now the 7th one. If mod of I plus Z is equal to mod of I minus Z, show that Z is real. 8th, 1 plus AI into 1 plus BI into 1 plus CI is equal to P plus IQ. Prove that P into tan inverse A plus tan inverse B plus tan inverse C equal to Q, and 1 plus A square into 1 plus B square to 1 plus C square is P square plus Q square. Nine. P equal to A plus IB and Q is equal to A minus IB. Prove that P e raised to P plus Q e raised to Q is real. Of course, given that A and B are real. So these are the next three problems. Now I suppose they are a bit simpler one. Like the second one is very simple. Or no? This is mod. This is Z1, Z2, Z3. So mod Z1 into mod Z2 into mod Z3 equal to mod Z4. वो तो आ ही जाता है. एंड सिमिलरली आर्ग्यूमेंट्स में अगर आप देखेंगे तो इसका आर्ग्यूमेंट आता है tan इनवर्स A, tan इनवर्स B, tan इनवर्स C इक्वल टू tan इनवर्स Q बाय P. लेकिन एडिशन कैसे होता है? तो ईच नंबर, सी I can simply say that for the 8th one it is R1 e raised to I theta 1 into R2 e raised to I theta 2 into R3 e raised to I theta 3 equal to capital R e raised to I phi. Okay. So equating arguments we will have R1 into R2 modulus equate करके we will get this. And left hand side में it will be e raised to I into bracket theta 1 plus theta 2 plus theta 3 is equal to e raised to I phi. So theta 1 plus theta 2 plus theta 3 is phi. Now R1 is root of 1 plus A square, root of 1 plus B square, root of 1 plus C square equal to root of P square plus Q square. You square it, second one is proved. And here tan inverse A plus tan inverse B plus tan inverse C is tan inverse Q by P. So take tan here. So it is tan of tan inverse A plus B is Q by P and multiply by P. So 8th is simple. What about the first one? For that again we can follow the same policy, x plus Iy, and we should get y as 0. It is x plus Iy substitute karo, so it will become x plus I into bracket y plus 1 and this will be minus x plus I into bracket 1 minus y. Take the mod, square it, equate it, and you will find that the imaginary term cancels. It will be only the real part. Matlab y cancels, y will become 0. So it will be only in terms of x. What about this? This problem is a bit different one. If we start with p e raised to p plus q e raised to q, now e raised to p, when we say, it will be e raised to a plus ib, that is e raised to a into e raised to ib, but p itself will be in terms of r e raised to I theta. So how do we proceed? Or should we proceed like that only? A plus IB e raised to a plus IB plus a minus IB e raised to a minus IB, suppose, and we multiply. So it is a plus IB. I will split it as e raised to a into e raised to IB, right, plus a minus IB. It will be e raised to a into e raised to minus IB. Yes, then I can take e raised to a common throughout. What remains is a e raised to IB plus IB e raised to IB plus a e raised to minus IB minus IB e raised to minus IB, right? I'm not going to write beyond this. And e raised to IB, you write it as cos IB plus I sin IB, cos B plus I sin B, cos B plus I sin B, like that, and several cancellations will take place, and we want to prove it to be real. That means all the coefficients of I will simply vanish. Sin B terms should vanish. Cos B plus I sin B येणार आहेत ना सगळीकडे. This is cos B plus I sin B, cos B plus I sin B, and cos B minus I sin B, cos B minus I sin B. We multiply, that is the easiest way. फक्त तो e raised to a बाहेर काढल्याने जरा सोपं पडतं, right? So you should try 8th, then 6th, and then 9th. हा पटकन होईल. So in the last one we said that we will start with p e raised to p plus q e raised to q as a plus ib e raised to a plus ib plus a minus ib e raised to a minus ib. In the next step we have splitted it as e raised to a into e raised to ib plus a minus ib into e raised to a e raised to minus ib. So e raised to a is taken common. It is a plus ib into cos b plus I sin b plus a minus ib into cos b minus I sin b. And then we multiply regularly as, so it is a cos b minus plus a I sin b plus bi cos b. Rather I will write it other way around, ia करके ही लिखता हूँ. It is ia sin b ib cos b and then minus b sin b are the four terms here, and those four terms will be again a cos b. Second term will be minus ia sin b. Third term will be I minus ib cos b, and last term will be minus minus plus, minus minus plus, and again minus b sin b. And we are just through, I suppose. Terms of ia and ib got cancelled. So what remained is only real. There was no I into it. and if the 7th is still incomplete, then it becomes I plus x plus iy equal to I minus x minus iy. So it is x plus I into bracket y plus 1 mod of it equal to minus x plus I into bracket 1 minus y. If we take mod and square it, it is x square plus y plus 1 bracket square will be equal to x square plus 1 minus y bracket square. So it is x square plus y square plus 2y plus 1 equal to x square plus 1 minus 2y plus y square. So practically everything cancels. X square cancels, y square cancels, 2y divided 1 cancels, and you will get 4y equal to 0. Therefore y equal to 0. Therefore z equal to x plus iy is simply x plus 0i. So it is real. Anybody still writing this? Okay. Now the next part. It is De Moivre's theorem. De Moivre's theorem. Only the name is new. Actually, we know what is to be done. He says that cos theta plus I sin theta bracket raised to n is nothing but cos n theta plus I sin n theta. See, as we know that cos theta plus I sin theta is e raised to I theta, there is hardly anything into it. Once the moment you write it in the e raised to I theta form, it is e raised to I theta bracket raised to n. Obviously, e raised to I theta bracket raised to n is e raised to I n theta. Only thing that we should know is e raised to I theta is cos theta plus I sin theta. So this is obvious. Now the next set of problems will be totally based on it, right? And we will have to simplify it and write it in the form like, see the problem. It is cos 2 theta minus I sin 2 theta bracket raised to 7 into cos 3 theta plus I sin 3 theta bracket raised to minus 3 upon cos 4 theta plus I sin 4 theta bracket raised to 12 into cos 5 theta minus I sin 5 theta bracket raised to minus 4 minus 6, and he says simplify. This is the type of problems that we will be facing. Now first of all, if we accept this, then one should also accept that 1 upon cos theta plus I sin theta is nothing but cos theta minus I sin theta. It is actually 1 upon e raised to I theta is e raised to minus I theta, and e raised to minus I theta will be cos theta minus I sin theta. So here we will try and write this. ये कैसे लिखेंगे? Because we want to have all of them with the same angle, say theta, and that to cos theta plus I sin theta. So how will you write this? You will write it as cos theta plus I sin theta bracket raised to minus 2 is this bracket. You agree? because by this theorem raised to 2 will be cos 2 theta plus I sin 2 theta, raised to minus 2 will be cos 2 theta minus I sin 2 theta. Okay, so this raised to 7. The second term I can write it as cos theta plus I sin theta bracket cube raised to minus 3. Like that you simplify and give me the answer as cos theta plus I sin theta raised to total कितना आता है? I can do it orally. It is minus 14 minus 9, ये भी आएगा 48, ऊपर जाके minus 48, ये आएगा plus 30, वो ऊपर जाके minus 30. You will have to add. Answer comes out to be something like cos of 107 theta minus sin of 107 theta. Okay, but we use De Moivre's theorem and not this power. One can easily write in e raised to form and you will directly get it, but हमें ऐसे करना है, that is to be remembered. So just complete this problem. So this is our first one, and second one I will give it to you. You tell me कैसे करना है. How will you do this one? Is on the similar lines, but you will have to find out the r. R will be under root of 1 plus 3. So numerators R will be 2 and denominator का भी R 2 ही है, and argument ऊपर का क्या आएगा? tan inverse root 3, that is pi by 3, and this one minus pi by 6. So the moment you get it in that form, try to get everything in terms of cos pi by 6 sin pi by 6. Because cos pi by 3 you will write it as cos pi by 6 plus I sin pi by 6 square. So it is 2 pi by 6 means pi by 3. So get everything in terms of pi by 6 and solve it in the similar manner. It is 2 raised to 13 upon 2 raised to 11. So 4 will be outside. And then अंदर cos का क्या आता है वो देखना है हमें. It is like that. 4 cos of pi by 6 plus I sin pi by 6. It comes straight. So it is, third problem is 1 by root 2 plus I by root 2 bracket raised to 10 plus 1 by root 2 minus I by root 2 bracket raised to 10, and this is 1 plus I, 1 plus I root 3, and I into 1 minus I root 3. This is again to be done by r e raised to I theta. And fifth is 1 plus I root 3 bracket raised to 8 plus 1 minus I root 3 bracket raised to 8. And after that we will stop and move on with drawing. इसमें तो खैर cos pi by 4 I sin pi by 4, cos pi by 4 minus I sin pi by 4, and cos terms will remain positive, sin terms will have opposite sign, and so they will cancel. So your answer is likely to be what? 2 cos of 10 pi by 4. That you need to simplify. You will have to have angle between less than 2 pi. And here also it will be the same way. This is cos pi by 3 So it will be 2 cos of 2 raised to 8 into cos of 8 pi by 6. So actually these problems can be asked in online, because you can really do them orally. It's nothing difficult into it, right?